In this lesson, we'll learn what mixed numbers are and how to visualize them. To develop an intuitive understanding of mixed numbers, we will be using some visualization techniques throughout this lesson. Let's start with the whole number 1 and see how we can represent it as a fraction. The goal of this lesson is to understand mixed numbers better, so we're going to use shapes to represent whole numbers, fractions, and mixed numbers. Let the whole number 1 be represented by the rectangle shown. Now we divide the rectangle into 5 equal parts. Whenever a fraction has the same number on top and bottom, it equals 1. Think of it like having a whole pizza pie cut into slices on a tray. If you take all the slices from the tray and place them on your plate, you have the whole pie again, which is equal to 1 pie. As you can see, the rectangle is divided into 5 equal parts. The fraction below the rectangle represents these divisions. Look at our fraction. The number on top tells us how many of these rectangular parts that divide the whole rectangle are colored in. That number is called the numerator. The bottom number tells us how many equal parts the rectangle is divided into. That number is called the denominator. Look at our rectangle. We can change the fraction by coloring fewer parts. Let's remove 3 blue parts from the rectangle. The rectangle is now an exact visual representation of the fraction immediately below it. Let's put the 3 blue parts we took out back in the rectangle. Instead of removing blue parts from the rectangle to change the value of the numerator of the fraction, let's add 1 to the numerator. Our rectangle currently shows 1 whole, 5 over 5. But it doesn't match the new fraction of 6 over 5 yet. What could we do to the rectangle to show 6 out of 5 parts? Pause the video now and take a few minutes to think about it. Resume playing when you're ready to compare results. When the number on top, numerator, is bigger than the number on the bottom, denominator, we call it an improper fraction. Fractions typically represent a part of a whole, not more than the whole itself. Think of it like ordering a whole pizza pie cut into 5 slices instead of the typical 8 slices. You then order 1 additional slice, cut from a pie of 5 slices. You leave the pizzeria with 1 whole pie, 5 slices, and 1 additional slice from another whole pie that's still in the pizzeria. We see that all the blue parts together make 6. But each rectangle can only hold 5 blue parts, because that's the number of slices in a whole pizza pie. So since we have 1 extra blue part that doesn't fit, we need another rectangle to hold it. Look at our fraction. We can write it as the sum of 2 fractions that share the denominator of 5, the number of slices in our whole pizza pie example. Let's use the pizza pie analogy again to better understand the fractions and rectangles shown. Imagine Amy purchased 2 whole pizza pies to bring home for dinner. The pizzas she ordered are cut into 5 slices instead of the typical 8 slices. Before leaving the pizzeria, she decided to eat 4 slices. The leftmost fraction shows a whole pizza pie cut into 5 slices with no slice eaten. The middle fraction shows a whole pie with 1 slice left. She ate 4 slices. And the rightmost fraction shows the 6 slices Amy brings home for dinner from 2 pizza pies she ordered. Great, but what does this have to do with mixed numbers? Many real-world scenarios deal with whole objects and leftover parts, just like our example with pizza pies. Mixed numbers make it easier to visualize the quantity represented by the fraction. Let's modify this example a bit to drive the point home about how mixed numbers make it easier to represent quantities. Suppose Amy buys 3 pizzas this time instead of just 2, but she still eats 4 slices. Note the added rectangle and fraction that shows the third purchased pizza pie. The first 3 fractions don't do a good job of showing Amy's current quantities of pizza pies, because the mathematical expression is somewhat lengthy. What about the last fraction of 11 over 5? Can you easily tell how many whole pizzas and leftover slices Amy is bringing home for dinner just by looking at this fraction? Not really, right? Let's work on converting the left-hand side expression to a mixed number. First, we can simplify the fractions that have the same numerator and denominator value. Remember, whenever a fraction has the same number on top, numerator, and bottom, denominator, it equals 1. That's like one whole pizza pie cut into 5 pieces without any of the slices eaten. Next, we add the whole numbers. And finally, we drop the plus sign. The mixed number shown, in addition to a numerator and denominator, has a leading whole number component of 2, where 2 is the number of whole pizzas Amy is taking home for dinner. Seeing this mixed number, we can easily conclude that Amy is bringing home for dinner 2 whole pizza pies and 1 loose slice from a pie that was cut into 5 equal pieces. Thanks for watching. If you found this video helpful, consider leaving a like. If you're new to the channel, hit that subscribe button for more amazing videos.